In this lecture, we will explore through the static fields. Static fields are the fields that are declared inside the class along with the static keyword. But static fields will not be stored inside the object. Static fields are stored outside the object, that is in the class memory. Yes, in the heap, separately the class memory will be created. In this case, inside the class memory, all the static fields are stored, because static fields are common to all the objects of a class. So whenever you want to store some common data that belongs to all objects of the class, then you require to use the static fields. For example, we have a class called bank account. For every bank account, there must be an account number, account holder name, and current balance of the particular bank account. These three details are individual for every bank account because every bank account will have its own number, its own holder name, and its own balance. But if there is any common data that belongs to all objects of the bank account, that is to all bank accounts, you require to declare that field as a static field. For example, assume all the bank accounts are created in the same bank, so you require to store the bank name as a static field. That means the bank name is common for all the bank account objects. So in this case, in the objects of the heap, the static field, that is bank name, will not be stored. See, the first object has account number, account holder name, and current balance only, but doesn't store the bank name. Even the second object also. So every bank account object has its own account number, its own account holder name, and its own current balance individually. This is called isolated objects. But common to all objects of the same class, in the class memory in the heap, the value of static field will be stored. So this is common for all the objects. So overall, whenever you find out some data is common to all objects, then you require to use the static field. Let us compare instance fields and static fields. Instance fields are stored inside the objects. Static fields are stored in the class memory. Both are stored in the heap. So static fields will not be stored inside the objects. Here, instance fields are the non-static fields. That means the normal fields that you have created already in the previous application. So you can call the non-static fields as instance fields. Instance fields are related to respective object, but static fields data is common to all objects of the same class. Instance fields are declared without static keyword. That means they are created with regular syntax. But in order to declare the static field, you require to use the static modifier while declaring the field. Instance fields are accessible with object only. Without object, instance fields cannot be accessible. When you talk about outside the class, you require to create object and you require to store the object reference in a variable that is called reference variable. And overall, through the reference variable only, instance fields are accessible. But static fields are accessible irrespective of the objects. That means static fields are not accessible with objects. They are accessible through class name. So always you will access the static fields as class name dot field name. And instance fields are allocated separately for each object because instance fields are stored inside the object. But static fields are stored outside the object. Its memory will be allocated when we access the class name for the first time while executing the program. So assume in the main method we have accessed the class name in the 10th line. So while executing that 10th line only, the static field memory will be allocated not prior to that. So overall, if you don't access the particular class in the entire program, the static field memory will not be allocated at all. On the other hand, if you don't create any object, the memory of instance fields will not be allocated, because instance fields only will be stored inside the object. Instance fields memory will be separate for every object. Static field memory will be allocated only one time throughout the entire program, irrespective of number of objects. Static field doesn't mean that fixed value. Static field value also can be changed at any point of time. That means static fields are not constants. Only the point is, static fields are common to all objects of the particular class. So let us take a real-world example. Suppose there are 30 students in a classroom. So each student has their own student ID, student name, and marks. These are examples of instance fields. And the teacher name, room number is common for all the students. So those are examples of static fields. So in the fields example application, we have already created a class called product with 4 fields. So those are by default instance fields because we have not declared them with static modifier. So if you add the static modifier, then it is called as a static field. For example, I want to create a static field to store total number of products. It is static because the total number of products is common for all the products. And this static field is accessible along with the class name only. The static field is not accessible with the object, that is with the reference variable. So you should access this static field as product dot total number of products, because product is a class name and total number of products is a static field name. So come back to the console application, that is in the main method. After creating a new object for the product class, try to increment the value of static field by accessing the static field as product dot total number of products. And after creating the second object, once again increment the value of total number of products, and even after creating the third object also. The default value of static field is 0 because the data type is int. And 0 becomes 1 in this case, 1 becomes 2 in this case, 2 becomes 3 in this case. So overall, by the end of this statement, the value of total number of products will be 3. And at the end of the application, print the value of static field, that is product dot total number of products. So the expected output will be 3. So as you can guess, the total number of products is displayed at the bottom of the application. This total number of products will not be stored inside the object, but will be stored individually in the class memory. And when it will allocate the memory of the static field? The static field memory will be allocated when you access the class name for the first time. For example, above, assume there are 10 lines of code here. So while executing these 10 statements, as you have not accessed the class name even for the first time, the static field memory will not be allocated. But when you access the class name for the first time, then the static field memory will be allocated. And you can change the value of the static field any number of times. It is not a fixed value. And you cannot access the static field by writing the reference variable name, because the reference variable refers to object and the object doesn't store the static fields, right? So overall, we cannot access the static field with reference variable. But static fields are accessible even without the class name directly in the methods of the same class, that is within the same class itself. So if you create a method in the same class, you can directly access the static field without writing the class name. So if you want to access the static field outside the class, you must write the class name dot field name. But inside the same class, you can directly access the static field by writing just field name, or even with the class name dot static field also. You can use either of the statements to access the static field in the same class. But you will understand more about methods in the next section, so don't confuse about the methods as of now. This is all about static fields in C#. In the next lecture, we will understand about constants.